Hi, welcome to my video series. Tonight I would like to basically give a talk on an overview of limits. As you may have noticed, most calculus textbooks are notorious for dealing with precise definitions of mathematical objects. They outline the steps and the rules and mathematical symbols, but do not often explain what that definition means. So in this video, I will look at what a limit actually is before you have to get too crazy with the mathy part of things. Well, let's just start with a simple function. We will call our function f of x. As you can see, this function does some really cool things. It stops, it skips, and even has a hole in it. Now, what we're interested in is what is the value of the function near a specific x location, or what does the function intend to do at that x location. Now, that's all we want. By looking at the function, sometimes it's very easy to see that, specifically if the function is continuously and smoothly curving. We just simply have to read the coordinates off the function. Now, even my cat can do that. What we want is we want some excitement. So we want to look at the function to see where the cool stuff happens. Now, if you look at our function, you'll see that right on the left over here, something neat happens. I've got a hole in my graph. That's exciting because we don't even have an x value to get a coordinate from. Now remember, we're not interested in what the value of the function would be at the x value, but rather what is the value of the function near the x value. The best way to think of that is think of the function as train tracks. And you have two trains heading toward a specific x value from the two different directions. We will call the x value the train station, and all we want to know is if the two trains go to the same station so that passengers can exchange trains. If the answer to this is yes, then we can obtain the address of the train station from either train's GPS system. The trains do not actually have to touch. So if we take our train and we approach the train station from this side or this side, and as the two trains approach the train station, if the two trains have the same GPS location when they get to the train station, then we know that we have a value. That is, the trains approach the entrance of the train station, one on the left, the other train on the right. The passengers can exchange trains. Their GPSs will get the same address at the train station. That is the value of our function, even though the tracks do not even touch each other. I guess you may want to think about it as the engineers wanted to save some money and not have to worry about the tracks going through the train. So as we approach the train station A from either side, if we get the same value, then we say that we actually have an address for the train station, and that train station's address is typically L. Mathematically, you will see it written this way: the limit of f of x as x approaches A is L. That is, as our two trains approach A from either side, if both trains we have the same GPS value as L, then we say the limit exists and the limit of our function is L. Now, if we look at this location, even at this value over here, we have some cool stuff even happening. So I can get it right about here. Really neat stuff happening there. This is weirder, right? Because you have the two trains each going and following their own train tracks. This train goes to this, and this train goes to this location, and both of them come to the station, but the stations have different GPS values. In fact, we actually do have a train station that's floating in between. So if one passenger train approaches from the right side, it gets its GPS value. The other passenger train approaching from the left side has its value, even though we may even have a train station that has its own address. There's no way for the passengers to exchange trains. In this situation, we say that the limit of the function does not exist. The two GPS locations are different. to summarize, just remember the limits do not care if the train station has tracks going through it. All we are interested in is that the two train tracks go to the same station. It is simple as that. If the answer to that question is yes, then the limit exists, and the GPS coordinates from either train will give the same value. And if the two trains have different GPS coordinates, then we say the limit does not exist.